Good day, I'm Ding Pei Won, and my teammates are Ang Zijun and also Sim Jalil. We are from Group 1. Sin and I will be presenting about Task 1, and will be one who talk about on Task 2. So the first one, Amazon RDS, Relational Databases. The Amazon Relational Databases Service RDS is a fully managed database service provided by Amazon Web Services AWS, designed to simplify the setup, operation, and scaling of relational databases in the cloud. Among its supported database engines is MySQL, which is the chosen database for the current iteration of the application. This compatibility ensures a smooth transition and easy migration of the application database to the AWS infrastructure. One of the key advantages of Amazon RDS is its automation of routine database administration tasks, such as backups, patch management, and replication setup. This automation reduces the burden on the client's team, allowing them to focus more on application development and less on database maintenance. Additionally, Amazon RDS offers features like high availability and scalability, ensuring that the application remains accessible and responsive even during periods of high demand. These capabilities align perfectly with the client's requirements for a dependable, scalable, and easy to maintain database solution, enabling them to confidently handle growth and fluctuation in workload without sacrificing performance or reliability. The second one is Amazon EC2, Elastic Compute Cloud. Amazon Elastic Compute Cloud is a web service that provides reliable compute capacity in the cloud, allowing users to run virtual servers known as instances on which they can run their own application. By leveraging EC2, the current iteration of the application will be hosted on cloud-based servers rather than the client's local infrastructure. This shift offers numerous benefits, including enhanced flexibility, scalability, and reliability. EC2 enables users to easily configure and customize their virtual service to meet the specific requirement of their application, ensuring optimal performance and resource utilization. Moreover, EC2 excels in its ability to handle massive workloads, thanks to its elastic nature that allows users to dynamically scale compute resources up or down based on demand. This scalability ensures that the application can seamlessly accommodate fluctuation in traffic and workload without experiencing performance degradation or downtime. Additionally, EC2's reliability and availability are backed by AWS robust infrastructure and global network, providing users with a highly resilient hosting environment for their mission-critical application. Overall, by leveraging Amazon EC2, the client can benefit from improved performance, stability, and availability, reducing the operation overhead association with managing on-premise.
For storage, we select Amazon S3. It provides object storage to a web service interface, with its main selling point being its low latency and scalability. The Amazon S3 allows for quick storage and retrieval of image, which wonderfully aligns with our client needs for displaying images or on their e-commerce platform. Amazon SGS and SNS are our go-to service for reliable email and notification delivery, a critical component of our customer communication strategy. With this AWS module, we aim for a seamless, scalable, and efficient digital environment.
So now, let's get into the implementation of the application. But before we actually move into the implementation part of the application, it is important that we first go through the database design. As you can see here, we have three tables that are named customer, product, and seller. And each of them have slightly different values that you put in the table to ensure that each data that is stored in the respective table is the appropriate data that we actually need to store. Now onto the implementation steps. So the first two steps will be to install and configure the web server and the MySQL workbench on your local PC. And after that, we can create a database on the Amazon RDS platform and carefully configure the multiple security measures that are available, such as setting the inbound and outbound rules and the master password. And if you have finished the first 3 steps correctly, you should be able to connect to the newly created database through your MySQL workbench with no problem. And once you're done with that, you can create the tables using SQL queries through MySQL workbench. So here are the SQL queries for creating the tables. As you can see in the first column, we have a use Taobao, and Taobao is the name of our database. So you have to first do that every time you want to do something to the database in order to make sure that it selects the database first. And followed by the use Taobao, we have 3 create table queries with all the relevant fields that the table needs to have. And once you have successfully executed all 3 of the create table queries, you should be able to see multiple successful outputs in the output section of your MySQL workbench. Now, in order to test the functionalities of the application, we have to first perform 3 different actions. The first one will be to insert a new entry to one of the tables. The second one will be to delete one of the old entries, and in this case, we'll be deleting the entry that we inserted in the first step. And the third step is to insert another new entry to another table. So here are the SQL queries that can help achieve the testing. The first one uses an insert into query to insert an entry into the customer table. And as you can see, we have configured all the values to be the same as stated in the table itself. And once you have inserted the entry into the customer table, you should be able to see one successful output message on MySQL workbench. And we can then use delete from customer where ID equals to 101. And as you can see, ID equals to 101 it's the same ID as the one we gave to the customer entry that we just created in the first step. And if it's successful, then the customer that we have just inserted will be deleted, and you should see another successful output message on MySQL workbench. And we can then go into the third one, which is using another insert into query to insert a entry into the seller table. Now, on to securing the database. We are planning to secure it by encrypting the data using AES algorithm, which is a standard and secure encryption technique. We can also hash the passwords using SHA-256 algorithm, which is a one-way and secure hashing function. By using the SSL/TLS protocol to establish a secure connection between the server and the database, we can prevent eavesdropping and any tampering of data. We can also implement access control policies to restrict access to the database based on the user's roles and privileges, which can help us prevent unauthorized access and modification of data. We can also configure the Amazon RDS to perform regular backups and audits of the database for us. So this will help us ensure data integrity of all time and ensure that the database is available all the time, and to detect and recover from any data breaches or errors. Thank you very much. This will be all from our group.